Mercury vapor lamps are a type of high-intensity discharge head lamp that produce light by sending an electrical arc through vaporized mercury. These lamps are known for their high lumen output relative to the size, making them suitable for applications where bright, efficient lighting is needed. The operation of a mercury vapor lamp involves several key steps. Firstly, a voltage is applied across two electrodes within a quartz or ceramic arc tube. This arc tube contains a small amount of mercury and an inert gas such as argon. The argon gas facilitates the initial start-up of the lamp. Secondly, the electrical arc ionizes the argon gas, creating a conductive path for the current to flow. This initial arc generates heat which vaporizes the mercury within the tube. Thirdly, as the mercury vaporizes, the electrical arc begins to excite the mercury atoms. When these excited mercury atoms return to their ground state, they emit photons of light at specific wavelengths. These wavelengths primarily fall in the ultraviolet UV spectrum. Fourthly, to convert the UV light into visible light, the outer bulb of the mercury vapor lamp is coated with a phosphor. This phosphor coating absorbs the UV radiation and re-emits it as visible light. Different phosphor coatings can be used to adjust the color, temperature, and color rendering properties of the lamp. Mercury vapor lamps offer several advantages. Firstly, high efficiency. They provide a relatively high lumen output per watt compared to incandescent lamps, making them more energy efficient. Secondly, long lifespan. Mercury vapor lamps have a longer lifespan than incandescent lamps, reducing the frequency of replacement. Thirdly, compact size. They can produce a significant amount of light from a relatively small source, making them suitable for applications with limited space. Fourthly, good color rendering. Phosphor-coated mercury vapor lamps offer improved color rendering compared to earlier versions. Despite these advantages, mercury vapor lamps also have some drawbacks. Firstly, warm-up time. They require a warm-up period of several minutes to reach full brightness. Secondly, color shift. The color of the light produced by a mercury vapor lamp can shift over its lifespan. Thirdly, mercury content. Mercury vapor lamps contain mercury, which is a hazardous material requiring special disposal procedures. Fourthly, UV emissions. If the outer bulb is broken, the lamp will emit harmful UV radiation. Mercury vapor lamps are commonly used in various applications, including street lighting, industrial lighting, warehouse lighting, and security lighting. In street lighting, mercury vapor lamps provide bright, efficient illumination for roadways and public areas. In industrial settings, they are used to light large areas such as factories and warehouses. For security lighting, mercury vapor lamps offer bright, reliable illumination for deterring crime. The spectral characteristics of mercury vapor lamps are determined by the specific wavelengths of light emitted by the mercury atoms and the properties of the phosphor coating. Mercury vapor lamps emit a significant amount of light in the blue and green regions of the spectrum, which can give the light a slightly bluish tint. The phosphor coating helps to fill in the red portion of the spectrum, improving the overall color rendering. Different types of mercury vapor lamps are available with varying spectral characteristics to suit different applications. When selecting a mercury vapor lamp, it is important to consider the following factors. Firstly, lumen output. Choose a lamp with a lumen output that is appropriate for the size and layout of the area to be lit. Secondly, color temperature. Select a color temperature that provides the desired ambience and visual comfort. Thirdly, color rendering index (CRI). Choose a lamp with a CRI that is suitable for the application. A higher CRI indicates better color rendering. Fourthly, lamp life. Consider the rated lifespan of the lamp to minimize replacement costs. Fifthly, energy efficiency. Select a lamp with a high lumen per watt ratio to reduce energy consumption. Mercury vapor lamps are typically installed in fixtures that are specifically designed for them. These fixtures provide the necessary electrical connections and protect the lamp from the elements. It is important to follow the manufacturer's instructions when installing and maintaining mercury vapor lamps. Regular maintenance such as cleaning the lamp and fixture can help to maintain optimal performance. When replacing a mercury vapor lamp, it is important to use a lamp with the same wattage and type. Using a different type of lamp can damage the fixture or create a safety hazard. Mercury vapor lamps should be disposed of properly to prevent mercury contamination. Many municipalities offer recycling programs for mercury-containing lamps. The efficacy of a mercury vapor lamp is measured in lumens per watt, which indicates how much light the lamp produces for each watt of electricity it consumes. Higher efficacy lamps are more energy efficient and can save money on electricity bills. The lifespan of a mercury vapor lamp is typically measured in hours. The rated lifespan indicates how long the lamp is expected to operate before it fails. Lamp life can be affected by factors such as operating temperature, voltage fluctuations, and cycling frequency. The color temperature of a mercury vapor lamp is measured in Kelvin. Lower color temperatures such as 2700 Kelvin produce a warm yellowish light, while higher color temperatures such as 6500 Kelvin produce a cool bluish light. The color rendering index (CRI) of a mercury vapor lamp is a measure of how accurately the lamp renders colors compared to a standard light source such as daylight. A CRI of 100 indicates perfect color rendering, while a CRI of 0 indicates poor color rendering. Mercury vapor lamps are available in a variety of wattages ranging from 50 watts to 1000 watts or more. Higher wattage lamps produce more light, but also consume more energy. The choice of wattage depends on the size and layout of the area to be lit and the desired level of illumination. Mercury vapor lamps are typically used in applications where high light output and long lifespan are required. However, they are being replaced by more energy-efficient and environmentally friendly lighting technologies such as LED lighting. LED lighting offers several advantages over mercury vapor lighting, including higher energy efficiency, longer lifespan, better color rendering, and no mercury content. LED lights also offer instant-on capability and can be dimmed. Despite the advantages of LED lighting, mercury vapor lamps are still used in some applications where their high light output and relatively low cost are important considerations. However, as LED technology continues to improve and become more affordable, it is likely that mercury vapor lamps will be phased out in favor of LED lighting. When considering the use of mercury vapor lamps, it is important to be aware of the environmental regulations regarding their disposal. Mercury is a hazardous material and can contaminate the environment if it is not disposed of properly. Many jurisdictions have regulations requiring mercury-containing lamps to be recycled or disposed of at a designated facility. It is also important to follow safety precautions when handling mercury vapor lamps. If a lamp is broken, avoid direct contact with the mercury and ventilate the area. The use of mercury vapor lamps has declined in recent years due to the development of more efficient and environmentally friendly lighting technologies. However, they are still used in some applications where their high light output and relatively low cost are important considerations. As LED technology continues to advance, it is likely that mercury vapor lamps will be phased out in favor of LED lighting. In summary, mercury vapor lamps are a type of HID lamp that produce light by sending an electrical arc through vaporized mercury. They are known for their high lumen output, long lifespan, and relatively low cost. However, they also have some drawbacks, including a warm uptime mercury content and potential for UV emissions. Mercury vapor lamps are commonly used in street lighting, industrial lighting, and security lighting. However, they are being replaced by more energy-efficient and environmentally friendly lighting technologies such as LED lighting. When selecting a lighting technology, it is important to consider factors such as energy efficiency, lifespan, color rendering, environmental impact, and cost. LED lighting offers several advantages over mercury vapor lighting in terms of energy efficiency, lifespan, color rendering, and environmental impact. Therefore, LED lighting is generally the preferred choice for most applications. However, mercury vapor lamps may still be suitable for some specific applications where their high light output and relatively low cost are important considerations. The choice of lighting technology ultimately depends on the specific needs and priorities of the user. Consider a scenario where a large warehouse needs to be lit. The warehouse owner is considering using either mercury vapor lamps or LED lights. Mercury vapor lamps offer a lower initial cost, but LED lights offer higher energy efficiency and a longer lifespan. To make an informed decision, the warehouse owner should compare the total cost of ownership of both options, including the initial cost, energy costs, maintenance costs, and replacement costs. The warehouse owner should also consider the environmental impact of both options. LED lights are more environmentally friendly because they do not contain mercury and they consume less energy. Based on this analysis, the warehouse owner can choose the lighting technology that best meets their needs and priorities. The design of a lighting system involves several key considerations. Firstly, the desired level of illumination. The amount of light needed depends on the type of activities that will be performed in the space. Secondly, the uniformity of illumination. The light should be distributed evenly throughout the space to avoid shadows and glare. Thirdly, the color rendering. The light should render colors accurately to ensure that objects appear natural and appealing. Fourthly, the energy efficiency. The lighting system should be designed to minimize energy consumption and reduce electricity bills. Fifthly, the maintenance requirements. The lighting system should be designed to minimize maintenance costs and downtime. The selection of lighting fixtures and lamps is an important part of lighting system design. Different types of fixtures and lamps offer different performance characteristics in terms of light output, distribution, color rendering, and energy efficiency. The choice of fixtures and lamps depends on the specific requirements of the application. The control of lighting systems can be used to further improve energy efficiency and reduce operating costs. Lighting control strategies include occupancy sensing, daylight harvesting, and dimming. Occupancy sensors turn lights off when a space is unoccupied. Daylight harvesting reduces the amount of artificial light needed when natural daylight is available. Dimming allows the light level to be adjusted to suit the needs of the occupants. Regular maintenance of lighting systems is essential to ensure optimal performance and prolong the lifespan of the equipment. Maintenance tasks include cleaning fixtures, replacing lamps, and inspecting wiring. Proper maintenance can help to prevent premature failure of lighting components and reduce energy consumption. The installation of lighting systems should be performed by qualified electricians in accordance with all applicable codes and regulations. Proper installation is essential to ensure the safety and reliability of the lighting system. Incorrect installation can lead to electrical hazards and premature failure of lighting components. In conclusion, lighting system design involves a complex interplay of factors including illumination levels, uniformity, color rendering, energy efficiency, maintenance requirements, and safety. A well-designed lighting system can improve the visual environment, reduce energy consumption, and enhance the productivity and well-being of occupants. As technology continues to advance, new and innovative lighting solutions are constantly being developed. These new technologies offer the potential to further improve the performance, efficiency, and sustainability of lighting systems. In addition to mercury vapor lamps, other types of HID lamps include metal halide lamps and high-pressure sodium lamps. Metal halide lamps offer better color rendering than mercury vapor lamps and are commonly used in retail lighting and sports lighting. High-pressure sodium lamps offer higher energy efficiency than mercury vapor lamps and are commonly used in street lighting and security lighting. The choice of HID lamp depends on the specific requirements of the application. Furthermore, the NEC or National Electrical Code provides guidelines for the safe installation and operation of electrical systems, including lighting systems. NEC Article 410 covers the requirements for lighting fixtures, lamp holders, and lamps. This article includes information on wiring methods, grounding requirements, and overcurrent protection. It is important to follow the NEC guidelines when installing and maintaining lighting systems to ensure safety and prevent electrical hazards. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type and operating temperature. This table is used to determine the appropriate size of conductors for lighting circuits. In addition, NEC Section 210.21b2 specifies the maximum allowable load on a branch circuit based on the rating of the overcurrent protection device. This section helps to prevent overloading of branch circuits and reduce the risk of fire. When working with electrical systems, it is important to follow safe work practices and use appropriate personal protective equipment (PPE). PPE includes items such as safety glasses, gloves, and insulated tools. It is also important to energize electrical circuits before performing any work on them. Energizing circuits can prevent electric shock and other electrical hazards. In addition to the NEC, other standards and regulations may apply to lighting systems depending on the location and type of application. These standards and regulations may cover topics such as energy efficiency, light pollution, and disposal of hazardous materials. It is important to be aware of all applicable standards and regulations when designing, installing, and maintaining lighting systems. The evolution of lighting technology has been driven by the desire for more efficient, reliable, and sustainable lighting solutions. From the early days of incandescent lamps to the modern era of LED lighting, there has been a continuous stream of innovation and improvement. As technology continues to advance, we can expect to see even more exciting developments in the field of lighting.